So this is your given integral here. Now, if you see in this integral, you have an x square, and what you also know is that the derivative of x square is 2x. Okay, so what you do here is you put t is equal to x square. Then what happens? You get dt dx is equal to 2x dx, 2x. That means dt you get as 2x dx. That means what are you getting as x dx? X dx you are getting as half dt, right? So now you put it in this integral. Therefore, I is equal to integral. This x dx becomes your dt, half dt. Who's this? Yes. Now we had taken t to be x square. So put it x square tan inverse x square minus half log 1 plus t square. T square means t is x square. So this becomes x to the power of 4 plus c. That's it. Okay. So this was this. Let's see the next one. This one. Integral log of log x divided by x dx. How to do this? Log x divided by x. Now you know that the derivative of log x is 1 by x, right? So what you do is you put here t is equal to log x. So what do you get? dt dx is equal to 1 by x. That means you get dt is equal to dx by x. So what do you have here? This entire part dx by x, this becomes dt. So therefore, what does this integral change to? Integral log t dt. And how do you integrate log? Again by parts. Okay. So I'm doing directly. I've already done this for you, right? Log x in the beginning. So log t integral dt minus integral of derivative of log t, which is 1 by t, into the integral of dt, which is t, right? So this is t log t minus integral this t and this t cancel. So you simply get integral dt. So you get t log t minus t plus c. Now put back the value of t. We had put t is equal to log x. So this is log x into log x. Okay. Minus log x plus c. Okay. So this was an easy one. You just substitute. You just had to realize here that derivative of log x is 1 by x. That is what you had to realize here. Okay. Let us do this one. Integral x sec 2x minus 1 by sec 2x plus 1 dx. Okay. Now, first of all, here you change sec to cos in this integral. If you change sec to cos, what will it become? X 1 minus cos 2x by 1 plus cos 2x. Am I right?
Yes, sir.
You just write sec 2x is equal to 1 by cos 2x. Take the LCM in the numerator and denominator. This is what you're going to get. Now, what you do here is, you know that 1 minus cos 2x by 1 plus cos 2x is what? Tan square x, right? Formula. Remember multiple angle formula?
Yes, sir.
Yes, sir.
Tan square theta is equal to 1 minus cos 2 theta by 1 plus cos 2 theta, right? So now what you do here is, you can write this as integral x tan x whole square dx, right? Now, in order to substitute this integral, what you do is you can do directly by parts. Okay, you can do directly by parts. You can take tan x whole square as your first function, take tan x whole square as your first function, x as your second function, minus integral of derivative of, that is ddx of tan x whole square into the integral of x dx, whole thing dx. So this becomes half x square tan x square minus integral ddx of tan x whole square is how much? First you differentiate the power 2 tan x, and then you differentiate tan x, which is sec square x. And ours is the integral of x dx, it is half of x square, this dx. Now here what happens? This and this, they cancel. Okay. So what you do here is you take half x square tan x whole square minus, right, this has integral x square tan x sec square x dx. Okay. So now what you do here is take this as I1, half of x square tan x whole square. Take this as I1. Okay. So therefore, what is I1? I1 is equal to integral x square tan x sec square x dx. Okay. Now how to integrate this? Put t is equal to tan x, because we know that the derivative of tan x is sec square x. So that means what will I get? Dt dx is equal to sec square x dx. That means what do I get? Dt is equal to sec square x dx. So therefore, what does I1 become? Integral. Now, if t is equal to tan x, that means x is equal to tan inverse t, right? Right? So you put x is equal to tan inverse t.
Yes, sir.
Tan inverse t whole square. And we have put t is equal to tan x, and sec square x dx becomes dt. Okay. Now you integrate this again by parts. Okay. How do you integrate this by parts? Take your tan inverse t as your first function, integral t dt minus integral of derivative of tan inverse t whole square ddt tan inverse t whole square into the integral of t dt, and this entire thing has to be integrated. Okay, so this becomes half t square tan inverse t whole square minus integral ddt of tan inverse t is 2 tan inverse t. First differentiate the power and then differentiate tan inverse t, you get 1 plus t square. Okay, and this is half of t square dt. So here 2 and 2 they cancel out. Okay, what you are getting is t square tan inverse t by 1 plus t square. Let I is equal to integral sin inverse 3x minus 4x cube dx. Can you tell me how to do this sum? How to start this sum? Yes, anyone available? If you see, this looks like sine 3 theta is equal to 3 sine theta minus 4 sine cube theta. Okay, this is what it looks like. So what you do is you put x is equal to sine t. Therefore, what happens? You get dx dt is equal to cos t. That means you get dx is equal to cos t dt. Therefore, what is I become? Integral sine inverse of 3 sine t minus 4 sine cube t into dx becomes cos t dt. So this becomes integral sine inverse sine 3t by multiple angle formula into cos t dt. So this becomes sine inverse sine t sine 3t becomes simply 3t 3t cos t dt integral. You take 3 out of the integral, this becomes 3 cos t dt. Now you can integrate this by parts. First function, you take first function as your, because this is a product of algebraic and trigonometric. Okay, so according to that rule, you take algebraic function as your first function. So t integral cos t dt minus integral ddt of t into the integral of cos t dt, and whole thing is dt. Next, this becomes thrice. What is the integral of cos? It is sine. So t sine t minus integral dt of t is 1, integral cos t is sine t dt. That is 3 t sine t, and integral of sine is cos. So plus cos t plus c. Now you put back the value of t. You have taken, what have we taken here? X is equal to sine t. That means t is equal to sin inverse x. So you put it back. 3
Yes, sir.
sin inverse x into sine of sin inverse x plus, now what is cos t? Note here that if we have put x is equal to sine t, that means what is cos t? Root 1 minus x square. You put it here plus root 1 minus x square plus c, and you can simplify this. Get 3 times, get 3 times x sin inverse x plus root 1 minus x. That's it, plus c. Okay, any question till this part?
Yes, sir. Okay, sir.
Now what we come to after this is a very important part, which is called the recurring integrals. Okay, in by parts, recurring integrals in by parts. Recurring integrals in by parts integration. Okay, now what do you mean by these recurring integrals? See, let us take a very simple example here. Suppose you have an integral of the form, let I is equal to integral e to the power of 2x sine 3x. sine 3x dx. Suppose you have this kind of an integral. Okay, how do I integrate this? I should integrate this by parts because this is a product of two functions. One is an exponential function, the other is a trigonometric function. Okay, now you have a choice. According to Eilert rule, you should actually be taking the uh, exponential function as the second function. Okay, but when you
Okay, sir.
have product of an exponential function and a trigonometric function, according to Eilert rule, this should become your first function. In fact, this should become your second function, sorry, and this should become your first function, right? You can do it any way you want. That is, you can take this as your first function, this as your second function, this as your first function, or you can take this as your first function, this as your second function. Okay, so in this case, whenever you see this kind of an integral, e to the power of ax sine bx kind of an integral, okay, what you do here is you can take e to the power of 3x as your first function. You can take it as your second function also, no problem in this case. So you take this as your first function, e to the power of 2x, integral sine 3x dx minus integral of the derivative of e to the power of 3x into the integral of sine 3x dx, and whole thing integrated with respect to x. So what you get here now, you know that integral sine 3x is minus cos 3x, minus 1 cos 3x by 3. So this becomes minus twice, no, not minus twice. This becomes minus e to the power of 2x cos 3x divided by 3. Okay, minus integral of the derivative of e to the power of 3x. The derivative of e to the power of 3x is 3 e to the power of 3x. Okay, into the integral of sine 3x. Sine 3x, what is the integral? Minus cos 3x by 3, right? Dx. Now what happens? This 3 cancels off. So what do I get? Minus e to the power of 2x cos 3x by 3 minus integral, minus and minus combined to become give you a plus, e to the power of 3x cos 3x dx. Okay, now what happens is that again we integrate by parts. Plus first function, again you take e to the power of 3x as your first function, integral cos 3x dx minus integral of the derivative of e to the power of 3x into the integral of cos 3x dx, and whole thing you integrate with respect to x. That is what you get. So minus e to the power of 2x cos 3x divided by 3 plus, now what is the integral of cos 3x? It is 1/3 sine 3x minus integral of, now this is very interesting, this will going to get very interesting now. See, e to the power of 3x is here, right? So e to the power of, what is the derivative of e to the power of 3x? It is 3 e to the power of 3x, and integral of cos 3x is what? Sine 3x by 3 dx. Okay, Can you see the interesting pattern here? Yes, can you see the interesting pattern here?
What, sir?
See, and now tell me. This 3 will cancel. You again get e to the power of 3x sine 3x. What is this e to the power of 3x sine 3x? We started with this, isn't it? Yes, see.
Yes, sir.
We started with e to the power of 2x sine 3x. And after applying integration by parts, we are again getting e to the power of 3x sine 3x. So what to do?
Yes, sir.
What are we getting actually? What are we getting actually? Aren't we getting I back?
Yes, sir.
We are getting I back, right? See,
Yes, sir.
we started with I. See here, we started with I. And after all these steps, we are getting I back here. That means what is happening here? Therefore, we are getting, therefore, I is equal to e to the power of minus e to the power of cos 3x divided by 3 plus e to the power of 3x sine 3x divided by 3 minus I. Are we getting this or not? Yes, Govinda. That means we are getting I plus I is equal to minus e to the power of 2x cos 3x plus e to the power of 3x sine 3x whole divided by 3. That means we are getting 2I is equal to minus e to, if you take e to the power of if you take e to the power of, oh, this is all 2x. Okay, this is all 2x.
Okay, sir.
This is all 2x. Why did I write 3x? I don't know. This is all 2x. This is e to the, this should be e to the power of 2x. Okay, this all should be e to the power of 2x. Correct it. Okay, all
Okay,
of
sir.
this should be e to the power of 2x. So what are we getting here? If you take e to the power of 2x common, what are we getting? Sine 3x minus cos 3x divided by 3. That means what is I here? I is minus e to the power of, oh, I have taken minus sign outside. Then no need to take minus sign outside because I have already written sine 3x minus cos 3x. You're getting e to the power of 2x sine 3x minus cos 3x whole divided by 3. So you've got the value of I now. Hence,
Yes, sir.
what is I? Integral e to the power of 2x sine 3x is equal to dx is equal to e to the power of 2x sine 3x minus cos 3x divided by 3 plus c. That is your answer. Okay, so I stop here for today.